And in order to explain this whole closed business, we've got to go back to when we talked about numbers. When we talked about numbers, we had the big thing, which was all real numbers. Okay, those are all really the numbers that you know. There are some that you don't know. They're called imaginary number. Okay, and then every real number in the real numbers, there was another box. There were two more boxes that were called rational and irrational. This is not anything new, people. You have a big piece of paper on this. I don't even care if you really write this down for right now. Okay. Remember what the irrational numbers were? What were irrational numbers? Gabby? Pi was an irrational number, and Holly?
Decimal?
Nope.
Square root.
Square roots of numbers that don't work out.
Yeah.
Okay, those are irrational simply for the fact that they never work out. They're repeating decimals, it never stops. But under the rational numbers, we had a whole bunch of subgroups that fit in there. And if you remember, under the rational groups were all fractions and decimals. Under the rational group, we had integers. Remember what integers were? Integers were positive and negative whole numbers. And then under the positive and negative whole numbers, we had smaller groups that were the whole numbers. Again, this is not anything new for you all. And then under the whole numbers, we had a smaller subgroup that was the counting numbers or the natural numbers. This should not be mesmerizing to you in any way because we talked about this at length before. This is just helping me to get to where we are. Okay, the word closed. It's not an easy thing to really talk about. It's hard for me to explain it to you. Okay, but let me give you the question first, and then that'll lead me towards what the answer is to that, or what closed is. In the book, they asked you the question. Everybody remember what it was? The question was. Yeah, Kyle, give me it. What was it?
Choose every correct answer. The set of numbers is under.
Set of whole numbers
Numbers is closed under.
is closed under. Does it say what?
A addition.
Oh,
B
okay.
addition.
Let's do that. A addition, B subtraction, C is there multiplication, and D division. Are all four of those things there? Okay, what the word closed means in this case is that, okay, first of all, we're talking about the whole numbers. So let me just jot down examples of what whole numbers would be. Whole numbers are, whole numbers were every number starting with 0 that's positive, right? And so on forever that way. Okay. Whole numbers, they're asking you, things are closed if when you take any whole number and add it to another whole number, your answer will always be a whole number. Okay? In other words, if I take 5, which is a whole number, and add 4 to it, which is a whole number, do I get and will I always get a whole number for my answer? If that's the case, it is closed. It means it's kind of in its own little world. It isn't open. You know, but you have to think of a bunch of examples. What about 21 plus 107? If I add those two whole numbers together, will I get a whole number? I get 128. So the answer for addition is yes, it is closed under addition. Then you go and think about subtraction. 8 minus 4. Two whole numbers. When I subtract those two whole numbers, do I get a whole number? I get 4. Well, let's try another one. 9 minus 8. Do I get a whole number? Yes. What about 6 minus 8? 6 minus 8 is -2. Is -2 a whole number? It is not. -2 is an integer. It's a level up. So subtraction is not closed for whole numbers. Because you can subtract two whole numbers and get something that's not a whole number. Are you with me, Andrew? What about multiplication? Would whole numbers be closed with multiplication? Would whole numbers be closed with multiplication? Taylor says no. So Taylor, in order for that to be true, you have to give me two whole numbers that I could multiply together that would not give me another whole number. You have to prove your case. You said it wasn't closed.
I thought, no, never mind.
Give me two whole numbers that you could multiply together that would not give you an answer that's a whole number. I don't believe it can be done.
Yeah.
Two whole numbers, yes.
I was gonna say fraction.
Fractions aren't whole numbers.
I was gonna say -2, but
That's not a whole number either. So, under multiplication, it is also closed. How about division? Can you give me two whole numbers that when you divide them, you get something that's not a whole number? Kendall?
108 divided by 8. Wait, no, the other way around. 8 divided by 108.
8 divided by 108, which would really be 8 divided by 108, which you are right, because that would end up being either a decimal or a fraction. Anytime you divide if it doesn't work out evenly, it's going to give you a rational number, not a whole number. I mean, there are some cases where it would work. For example, 8 divided by 4 is 2, but not every case works. Once you start dividing a smaller number by a bigger number, you're going to get a rational number. So this is not closed. Okay. And that's what the whole closed thing means. Okay, if you can do that under there, then whatever. There's a whole bunch of other examples. It's not probably a huge thing that if you don't quite get right now, it's gonna like ruin your life. I don't think, but it is a thing.